All right, now we're going to look at a situation where we're trying to count up how many arrangements we can make from the letters in the word more. Okay? And we're going to compare that to how many different arrangements we can make from the letters in the word less. Okay? So I need to pull a document up from Canvas that I haven't pulled up yet. So let me go grab it. So we're going to look at the number of different words we can make from the letters in the word more versus the letters in the word less. Okay, so let me pull that up. I'll show it to you later. Let me download it. Okay. All right, so the difference between these two is that if I had the letters M, O, R, and E on slips of papers in a bag, I'm going to reach in and pull them out, and then arrange them. The first one I pull out, I'll put first. The second one I pull out, I'll put second. Then I might pick an M. And when I pick them out, I've already used them, so they're just staying out of the bag, and I wind up with that arrangement. And that would be a different arrangement than if I reached in and pulled out an M first, and then I got an E, and then I got an R, and then I got an O. So the question is, those are just two possibilities. How many would I really wind up with? Okay. So again, a tree diagram could help us with this. If we were doing the tree diagram, when I reached in to get my first letter of the arrangement, so let's think about how I have four, I'm making arrangements of all four of these letters. When I reach in and I try to get my first letter, I have these to choose from. But after so four possibilities, but after I make that choice, then that letter has been used up, so then I'd only have three left. After the M, I'd only have O, R, or E. I'd still have three left if O were my first letter. It would just be a different three, right? So this is kind of hard to draw, so I've actually drawn it for you on another sheet of paper, so we can look at that in a minute. I just want you to kind of get the gist of it to start with, right? So I had four possibilities for my first choice, and then one of the letters is selected, so now there's only going to be three letters left for my second spot. Then after that, won't there only be two letters left? Okay, there, for each one of these, there would have only been two letters left. And then that means one last letter. So 4 times 3 times 2 times 1, that means I'd have 24 distinct arrangements I could make of the letters M, O, R, E. Okay, so I'm going to show you the tree if I had completed it. That's not what I want. I want my, where is it? There it is. Right? And so there's the 24 possibilities. Okay? See how there's that? Let me make it a little bit skinnier so you can see it all. And I don't need that. How do I get rid of that? Okay. And then I want you to see that whole page. Okay? So there are all the possibilities. Okay? So here's the 6 that start with the letter M, then there's 6 that start with an O, and so on. Okay? So we could have drawn it. You see how there's 4 possibilities for the first? Let me see if I can draw on that. Yeah. So see how there's 4 possibilities for that first letter? Let's see if I can move this out of the way. Then there's 3 possibilities when I'm choosing my second letter, 2 for the third, 1 for the fourth, which gives us 24 possibilities, and I could have counted them. Here's 6. Here's another 6. It's kind of a lag on this when I'm doing it. Here's another 6, and here's another 6. So there's the 24 different arrangements you would come up with. Okay? All right, now let me go back, and we're going to consider another scenario now. We're going to look at what about how many distinct arrangements I could make from the letters in the word less, okay? So there's a huge difference between these two situations. You see, on this one, if I had L, E, S, and S on a slip of paper, and you reached in to pull out a letter, maybe you pull out an S. And then the next time you reach in and you pull out a letter, maybe an E, and then so you've used up this S and this E. Next time you reach in, you get an L, and then the last time you get the other S, right? So maybe you did this one first, okay? Maybe this was your first, then this was the second one you picked, then you picked that one third and that one fourth, okay? All right, well, another possible arrangement would have been that you picked this one first, which would have been an S, then this one second, which would have been an E, then this one third, which would be an L, and then this one fourth, which would be an S. But when you look at it, okay, these would not look different. They're not different looking. So even though the S's, these S's were different, okay, you can't see the difference because they're physically the same thing. And so these would not be considered different. They're not different looking, and they're not considered different arrangements. So they're not different arrangements, okay? The problem is the word less has lookalikes. So we have to find out what to do when you're trying to create arrangements. You know, use all four letters to create distinct arrangements. You have to watch it if you have a letter that's been repeated like that, okay? So I want us to look at that situation, okay? All right, so let me get you to look at the tree diagram. So what I did for my tree diagram so that we could follow which letter went where is I labeled the first S a S1 and the second S S2, okay? And then I created the tree diagram for that. Where is it? There it is. All right, so let's take a look at it. So here's where I'm going to call the first S S1 and the second S S2. And then this one got really big and cumbersome. So remember, these would be the letters that I would have chosen for my first letter, okay? And then after that, there would be 3 letters left, okay? And then after I've selected my second letter, there'd be 2 possibilities, and then after that, just 1 possibility. And so what I did is I created this tree, and I actually made the list of all possibilities, but I distinguished the first S from the second one just so you could see what the problem is. So see, there's 24 outcomes here, but they're not all distinct because there's really not a 1 and a 2 on those S's. So let me mark then what we have for lookalikes. Wouldn't these 2 words really be the same word? And wouldn't these 2 really be the same arrangement? And then wouldn't these 2 be the same arrangement? So from that first column, you don't really have 6 arrangements, you only have 3 different arrangements. Okay, let's look at the next column. First 2, really the same arrangement. Okay, then let's see, this one and this one would be the same arrangement, and these 2. So again, you just have 3 distinct arrangements because a lot of them are lookalikes. Now, in the last 2 columns, the lookalikes are side by side. Okay, so these are lookalikes. Those are both just SLES. These are both SLSE and so on. SELS. Okay, SESL, SSEL, SSLE. Okay, so there we have 6. We don't want to count this as 1 and this as another one. We're just going to count that one time. So I have 6 different arrangements coming from the last columns. So I wind up with 12 distinct ones there. And the reason I don't have 24 is with that less situation, I have some repeated letters, which causes me to have arrangements that are actually lookalikes. Okay? So we're going to learn there's a way we can tackle that. We can handle that. All right? And so I want you to think about it, to think about the more versus less situation when you're trying to answer a question like how many different arrangements can you make. For this one, we could have just done 4 times 3 times 2 times 1 and come up with it. But for this one, we couldn't have done that because we have these lookalikes and we can't count them. Okay. So those has lookalikes, and so they wouldn't be considered a different arrangement. So like L, E, S1, S2 would look the same as L, E, S2, S1. They don't really have those numbers, so you couldn't tell. So on that one, it actually turns out to be that we had the 24 possibilities, but then we needed to get rid of the lookalikes, and so it turns out we could divide by 2 in this case and get 12. But let me show you where that formula really comes from. So I want to go down. I want to go ahead and let me go ahead and look at a problem that's related to that. And that's question number 10. If I wanted to know the number of distinguishable arrangements in the word attract, what I could do is look at how there are 6 letters. Okay? So I could sit there and do 6 times 5 times 4 times 3 times 2 times 1, but that would have produced a whole lot of possibilities, and some of those would have been lookalikes. What we're going to find is that what we could do then is divide by. We're going to want to divide by the number of times that a letter has been repeated. Okay? So we're going to wind up wanting to divide by A occurs twice, so we're going to want to divide by 2, and the T occurs 3 times, and so actually I'll explain this in the next video because actually I need to tell you about a factorial before I can fully explain it. So I'd have to divide by 2, and then I'd also have to divide by the number of ways you could arrange the 3 letters. How many different ways you could arrange 3 letters. There's 2 ways you could arrange 2 letters. That way or that way. That's why you divide by 2. But there's 6 ways you could arrange 3 letters. Right? And I could go on and show you those. If I wanted to. So I could go on and show you how I could do this and so on, and it'll turn out to be that there's 6 ways you could arrange 3 letters. So I'd need to divide by 6 to cut out the lookalikes. And so then I could work this out and find out there'd be 5 times 4 times 3, which would turn out to be 60. Did I do that right? Oh, I didn't count up right. There's 1, 2, 3, 4, 5, 6, 7 letters. So let me throw a 7 in there. Okay. So then there would be 7 times 20 is 107. Times 5 is 35. Times, 7 times 20. That's 140 times 3. So that would turn out to be 420. I'll do that better once I've told you what a factorial is.